Let's look at factoring with 4 terms. And whenever we're doing 4 terms, we're going to be using the method factor by grouping. So in this example, I've got 4 terms and we're going to group those off into pairs. So I'm going to group this first pair together and I'm going to group the second pair together. What we do then is we treat each of these as a little mini factoring problem. We're going to look for the GCF in each of these pairs. So that first pair is 3x cubed plus 9x squared. As I'm building that GCF, I want to start with my coefficients. So what goes into both 3 and 9? That would be a 3. So that greatest common factor would be a 3 for the number. And then for the variables, I want to pick up the lowest power on my x's. So I've got an x cubed and an x squared. So that means that I would want an x squared. Okay, let's do the same for the second pair. And as I'm doing the second pair, it's really important that you record the sign. You're going to see why here in a second. So the GCF. So again, we're going to go ahead and start with the coefficients, that 2 and the 6. Well, what goes into both 2 and 6? It's going to be a 2. I'm going to record that as a positive 2. The sign is going to be important. And again, I pick up the lowest power on the x's. Well, 6 does not have an x, so there is no common x. Now let's factor these GCFs out of each of the pairs. So I'm going to start with that first pair. And as I'm factoring out, I actually divide both of those terms by the GCF, 3x squared. But I'm not just dividing it out, I'm actually factoring it out in front as I'm dividing. And then I'm going to record what I've got left over in parentheses. Okay, switching to my red pen, let's cancel some stuff. So in this first term, I can cancel those 3's completely. For the x's, I've got 3 x's in my numerator, 2 x's in my denominator. So I can cancel 2 of the x's, which is going to leave me with a single x. Okay, next are the 9 and the 3. So dividing the 9 by the 3, I end up with a 3 plus a 3. And then the x squareds completely cancel, so I've just got that plus 3. Next, we're going to move over to that second pair in green, and I'm going to divide out my GCF for that pair, which is my positive 2. So dividing out, I'm going to do it as a positive 2, as a plus 2. I'm really factoring that out in front, so plus 2. This gives me that separation, right, that plus sign. So I'm dividing everything out by a plus 2. Let me grab my red pen. Let's go ahead and simplify what we can. So I can factor out or divide out that 2 completely, and I'm left with an x from that term. In the second term, I've got 6 divided by 2, and 6 divided by 2 is a positive 3. Now take a look at that x plus 3. That x plus 3 is going to act as my new GCF. So when I'm doing something by grouping, my goal is to find a brand new GCF that everybody shares. And in this case, that GCF is my x plus 3. So I really want to divide both of these terms now, and the term would be everything with a plus sign in between. I want to divide both of those terms by my new GCF. So the first term and that second term. Okay, so dividing it by my new GCF, which is an x plus 3 in parentheses, x plus 3 in parentheses. Whenever I divide out to factor, I'm actually just sliding that out in front. So I'm going to put an arrow here, and I'm going to slide that GCF out in front. And then I'm going to be left with a quantity in parentheses. Okay, and this first one, x plus 3 cancels, and I am left with that 3x squared, 3x squared. In the second one, same story, right? The x plus 3 cancels, and I am left with that plus 2, so plus 2. This is our completely factored answer, x plus 3. 3x squared plus 2. You can write it in either order with the x plus 3 in front or the x plus 3 behind. Let's get to that second example. Our second example starts out really similar. I've got 4 terms here, and I want to go ahead and group them off in pairs of 2. So I've got the first 2 there and the second 2. Once in a while, you're going to have to rearrange these, but these are set up really nicely for us. Let's go ahead and tackle the GCF in that first pair. So in that first pair, I'm going to start with my numbers. So what goes into both a 6 and a 3? That would be a 3. So I've got a GCF there, coefficient being a 3. And then I'm going to pick up the lowest powers on my variables. Now this one has two different variables in it, but I only have y's in these first terms. So y cubed and y squared, I pick up the lowest power, and that's going to be a y squared. Okay, with the second GCF, I'm actually into this one. I'm going to hang on to it for just a second. And the reason is because of this negative sign right here. So we're going to do the first GCF. This is a really great strategy. I'm going to factor out the first GCF, and that will help me decide what to use in terms of a positive or a negative sign on the second GCF. Okay, so let's go ahead and tackle that first GCF. I want to divide both of my terms by that 3y squared. As I'm dividing that out, I'm going to record it out in front, 3y squared, and then I'm just going to go ahead and keep track of what I've got left over. So dividing 6 by 3, I get a coefficient there of 2. I've got 3 y's in the numerator, 2 y's in the denominator on that first term, so I can cancel all but a single y. So I've got a y right here. Moving on into my second pair, I've got 3y squared divided by 3y squared. Now I'm going to bring the negative down first. Anything divided by itself is equal to 1. So I can cancel everything, but that doesn't mean I'm left with a 0. It means that I'm left with a placeholder here of 1. So I'm going to put the 1 there. So I know when I build my factorization over here for my second pair, I need that value inside the parentheses to match. So I really need to end up with a positive 2y minus a 1. So now let's go back up to the green pair. So as I'm looking at the GCF, I can see that I have an x in common. In terms of the coefficient, I have a 2 and then a 1 on the other one, so I don't have a coefficient in common. But I really want to have not a plus in the middle. I really want to instead have that negative sign in the middle. So instead of factoring out an x, I'm going to factor out a negative x. Okay, let's go ahead and watch and see how this works for us. I'm actually going to erase this here too. Let's go back to our pen. So as I'm factoring that out, I know that I am going to divide by a negative x and by a negative x. So that negative x comes out in front. Let me grab my red pen and we will record what we've got left over. Okay, so negative divided by negative is equal to a positive. I can cancel my x's and I'm left with the 2 and the y. Sorry, that's super messy, but I'm left with a positive 2y. So far, so good, right? I want to match what was in the other set of parentheses. Okay, going on to the x's. I have a positive x divided by a negative x. Now I know that I can cancel these, but I'm left with that placeholder of negative 1 this time. Positive divided by a negative is equal to a negative 1. Perfect. So I've got the exact value inside those parentheses, and I've created a brand new GCF for us. Let's go ahead and move on to that second step. In the second step, I'm going to divide out by that brand new GCF, which is a 2y minus 1. Divide this one by a 2y minus 1. Whenever I'm factoring a GCF, it actually slides out in front. So I've got 2y minus 1. And then in parentheses, I'm going to record what I have left. Okay, here I go. The 2y minus 1 completely cancels, leaving me with that 3y squared. And then the 2y minus 1 cancels also from this second part, leaving me with that negative x. So this becomes our completely factored form. Now you're getting the hang of it. So I know that I can group these into pairs. Oh, I did green first, so we'll just go with it. And then my blue. I'm going to use the same strategy that I used in the last example by doing the GCF for the first pair, and then we're going to tackle the second pair. Okay, so GCF here. So my GCF, between the 5 and the 10, a 5 goes into both of those, and then I'm going to pick up the lowest power on my a's, and that would be an a squared. Let's go ahead and divide this out. So dividing out my 5a squared, and then recording it out in front. 5a squared. I'm going to leave some room for what I've got left. Let me grab my red pen now. So I can cancel the 5 and the 5. I've got 3 a's in my numerator and 2 a's in my denominator. So I'm going to cancel 2 of them, leaving me with 1. So I'm going to write that as an a. In the second term, I've got negative 10 divided by 5. Negative 10 divided by 5 is a negative 2. And those a squareds cancel completely. So I know that when I put the second set of parentheses together over here, I know that I absolutely need an a minus 2. So I've got that new GCF that we're looking for. Well, I actually already have an a minus 2. But I still want to do the factorization so that I get everything that I need, those 2 sets of parentheses, when we're done. So our GCF in this case, GCF, when you already have what you need, you're just going to factor out the number 1. And the number 1 really acts as a super important placeholder. So what goes into both of those? Well, 1 is all that goes into both of those. So we're going to factor out not just a 1, but a positive 1. So I'm going to divide the a by a positive 1, the negative 2 by a positive 1, and that means I'm factoring that or sliding that positive 1 out in front. This is supposed to be a plus sign, that positive 1 out in front. So now that I've got this with my placeholder, and we're ready to do my second GCF factorization by factoring out that a minus 2. A minus 2. I'm going to slide that out in front. I'm actually going to write everything in black this time. So I'm going to slide out that a minus 2 in front. And what am I left with? I can cancel the a minus 2. Here I'm left with a 5a squared. And in the second group, I can factor out that a minus 2, and I'm left with, the sign is super important here, I'm left with a positive 1. You are doing great with factoring by grouping. I've got another video for you here.